Hello everyone, and thank you for attending today's webinar, High Performance Broadband Aggregation at the Edge, sponsored by Edgecore and IP Infusion. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your questions into the Q&A box and submit your questions to our speakers. All questions will be saved. If we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open on the screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Senior Principal Analyst, Sterling Perrin.
Thank you, Samuel, and hello. Welcome everybody to today's webinar on high performance broadband aggregation at the edge, sponsored by IP Infusion and Edgecore Networks. I'm Sterling Perrin, and I will be the host and moderator for the next hour. And I'm joined today by two speakers, of course, one from each of the key companies here. So we are joined by Shaji Nathan. He's Chief Technology Officer with IP Infusion. Hi, Shaji. Welcome back.
Hello. Happy to be here.
Looking forward to another discussion with you, Shaji. And Shaji today is joined by Nanda Ravindran, Vice President of Product Management with Edgecore Networks, and he's joining us from India. So late hour for you. Welcome and appreciate your time today. Hi, Nanda.
Yeah, thanks, Sterling. Hello, everyone. And thanks for having me and Edgecore at this webinar. Looking forward to present our ideas and answer your questions.
All right, yeah, and so with that, we'll of course hear, they'll trade off a bit through the topics as we go through. I'll make a market introduction, some of data from Heavy Reading, but also from our sister company, Omdia, just to set the stage in terms of the market drivers. Each of the two companies will give a very brief introduction of who they are, just for perspective in terms of the content. And then we'll move through our topics, open access, aggregation, and transport architectures, looking at key features for this area, a few deployment scenarios, use cases, or case studies, actually, and then ending with the summary of the value proposition. We should have about 10 minutes for questions at the end, so please do ask, as Samuel outlined, ask the questions electronically throughout. We'll gather them up and get to as many as we can. And we also have two poll questions today, so looking forward to your views on those. In terms of drivers, really the drivers for the edge and the aggregation really start in the access network. And from the access, there's really two dimensions. There's the mobile access and the fixed network access. So I'll go through both of those, starting with mobility. And the 5G mobile boom is really well underway at this point. And this is fairly recent, well, very recent Omdia research in terms of 5G mobile subscriptions globally out through 2026. Really one of the key points from this is that subscriptions are set to exceed 1 billion globally by the end of this year, which makes 5G already the most successful mobile generation in history based on that number of subscriptions in that amount of time. It really has been a phenomenal uptake of 5G, despite, we certainly hear a lot of the challenges along the way, but that is tremendous amount of progress in a very short amount of time. And those are global statistics. And so what we see on the access network from that already is cell site capacity, so the connectivity to the cell site, increasing from 1 gig to 10 gigabit at a minimum. When we look at architectures that require front haul, then it quickly goes to 25 gigabits. And when you look at kind of more hub sites within cell sites, hub macros, you could very easily get much higher than that connectivity out of the cell site. So capacity goes up, and also densification increases. So small cells really drive greater cell density. That's what a small cell is. And that requires more connectivity to each of these sites, and typically in places that have never been connected before. And fiber is the connectivity of choice when it can be done. So with that already underway, then the next phase that we're looking at is with the standalone 5G cores, as well as the push towards release 18, which the industry labels 5G Advanced. That combination is really going to enable a lot of the interesting use cases that we've heard about for years around 5G, around ultra reliable and the low latency types of communication. So today it's been about number of subscribers. Going forward, it's going to be number of subscribers combined with the new use cases and applications. And the fixed networks have not sat still through all of this. Fiber is really driving tremendous progress in fixed broadband. This also is very recent data from Omdia, and this is global average consumer broadband download speeds forecasted out through 2027. If we look at where we are in 2021, and this is global, on average, 159 megabits per second is the average download rate globally, expected to increase. Really, you can see a pretty phenomenal increase on that line to over 800 megabits through 2027. These are averages, so some regions will be less, but some will be significantly higher, actually, very much. A lot of countries in Asia moving into the gigabit age quite quickly. Fiber is the choice for this going forward, but even today, fiber share, and really driven by Asia and particularly China, fiber is already 61% of broadband connections, and that's set to increase. And then in many countries around the world, there's initiatives just, there's a very strong realization of the importance of fiber for broadband going forward. And we see initiatives, not just in the US with the Broadband Equity Act, with $42.5 billion of spending earmarked for broadband to new areas, rural areas, but also seeing similar activities around fiber in many countries around the world. So what does that mean for our topic, which is the edge of the network, the service provider edge, which also encompasses a lot of aggregation of a network. Edge and aggregation tend to go together. We know that the increasing capacity and the access is going to flow through into the edge of the network and require greater capacity in this portion of the network. That's at a minimum. When we talk about edge and aggregation in terms of scope and network elements, or infrastructure, there's several different components to that. There's, of course, switches and routers, things like broadband aggregation switches or cell site routers tend to be key elements there. There's also an important role for optical networking equipment, DWDM, very much an important technology for this portion of the network. And of course, as I've already alluded to in the access and backhaul networks, a very big reliability on fiber infrastructure, so fiber connectivity for all of it. Network requirements, and this is kind of like a sampling of just through heavy reading, research, and discussions. What are the key requirements for this portion of the network? Of course, scale. We're looking at 100 gigabits per second, scaling up to 400 gigabits per second, possibly higher. We can talk about that through today's webinar. But certainly as the access currency bandwidth goes up, the aggregation and edge needs to go up as well. In addition to capacity, there's just a lot of focus on flexibility as well as automation, and those two can be kind of intertwined as trends. But the flexibility at, of course, the switching layers and automation at the switching layers, layer 2 and 3, but also even down to the optical layer. Also a big focus, and this is really driven by what we're seeing in the access networks for both broadband, fixed broadband, as well as 5G reliability. So these edge aggregation networks also have to be highly reliable to keep that chain of reliability through the end-to-end connection. And then always on anything to do with kind of the plumbing of the infrastructure of the network, you have to do this at the lowest cost you possibly can. Those are the broad requirements for any, I think, any operator looking at this portion of the network going forward. Today's topic, we're focusing on disaggregation and white box, and that's why we have IP Infusion and Edgecore. And so there's a role for disaggregation in this portion of the network going forward, and that's really what I'll leave our speakers to explore in more detail. The key piece to keep in mind as we do that is kind of always measure that against the set of requirements. How do these white box and disaggregated network architectures meet these requirements, and how do they meet them compared to a traditional way of doing traditional, network infrastructure? Those are really the key things that I think network operators are looking at, and what I'm looking forward to hearing from our speakers representing both the software and the hardware side as they talk about the future of disaggregation in edge and aggregation connectivity. With that, let each of our speakers just give brief introductions of themselves and certainly their companies, and then we'll move into the heart of the discussion. So Ananda, again, welcome, and I'll let you give a brief Edgecore introduction, and then same for IP Infusion, and then we'll continue.
Okay, thanks, Sterling, for that great introduction. And so let me give a brief introduction about Edgecore Networks as to who we are and what we do. And Edgecore Networks is a full portfolio of switching and routing platforms provider, meaning white box provider, and also solutions. And we have shipped more than 3.3 million ports last year. We are a leader in open disaggregated networking, and we work with in a very flexible business model with service providers across all tiers. We understand to make open disaggregated networking successful, different service providers and their scale requires different business models, and we are open and ready to support that.
Hi, I am Shaji Nathan, and I'll talk a little bit about IP Infusion. We have been in continuous operation for last 20 years, providing solutions first that are standards-based for control plane, data plane, and management plane solutions that are IEEE, ITF, ITU-based solutions. And as the world started moving towards disaggregation, we started offering binary solutions. And our binary solution flagship product is Ocnos. We have over 500 plus customers and tens of thousands of deployments. And just like Edgecore, we have a flexible business model. We work with OEMs, ODMs, and carriers and customers alike. So essentially, we offer a full service portfolio of solutions that go all the way from edge to the data center. Over to you, Nanda.
Okay, before we start talking about solutions, we just want to summarize a few requirements and the kind of scale required in broadband aggregation. In the introduction, Sterling gave quite a high-level overview of what is going on in terms of trends in fixed broadband and the fiber-based broadband and the 5G, driving the requirements for mobile broadband. So when it comes to aggregation networks, one of the key requirement currently with what is going on in the network is that it should be able to support all types of access technologies. It should be able to support Ethernet, PON, cable, and wireless. Switching and capacity is another key requirement. We are looking at around 10 terabits per second of capacity in the aggregation networks, or even more. And this capacity and this level of aggregation networks needs to support silicon platforms from multiple vendors, be it Broadcom, Marvell, or Intel. In terms of routing features at the aggregation, IP MPLS, Layer 2, Layer 3 VPNs, and segment routing V6 are the key requirements. So packet optical transport. Packet optical transport is now a very key enabler for service providers. It enables service providers to do Ethernet transport in the most efficient, reliable, and cost-effective manner. And in terms of speeds, The current requirements are 400 gig. And in the very near future, we expect this to grow up to 800 gig and beyond. 400G ZR plus pluggable optics are the solution of choice for packet optical transport, and we expect this trend to continue for the near term. In terms of fiber broadband access, not only we need to have multiple vendors to be supported by the aggregation networks, we also need different PON technologies to be supported. For example, the XGS PON, the GPON, and even with the XGS PON, the new technologies coming with 25 gig and possibly 50 gig in the future. So now talking about 5G and what it means for aggregation networks, I mean, rather than requirements, I mean, I want to call as challenges. We all know about the requirements triangle whenever we talk about 5G. In the triangle, in one direction, we have the data rates growing in terms of 25 Gbps up to 20 Gbps. And in the other direction, the requirement to support an ultra low latency of less than an end-to-end latency of less than 1 millisecond. And then the other vertex of the triangle or the other direction where 1 million devices or more need to be supported in 1 square kilometer. I mean, these are requirements stretching the aggregation networks in 3 different directions. So this is a challenge we always pose our engineers developing these platforms. So the next point is about synchronization and timing. And as you all know, timing needs to be very accurate, especially in a 5G radio network. For its performance to be really good, the timing accuracy is critical. So from a telecom profile standpoint, the 8273.2 Class C spec is what needs to be met to have very good timing accuracy for 5G requirements. Hardening the design. This is another key challenge. The platforms not only need to be low footprint, should be able to get into a cabinet that is already out there. It needs to be power efficient, and power efficiency is something that is getting, more important by the day. And also these platforms being in the outdoors need to support a very extended temperature range. And talking about network architecture, I think it is key that the network is open, disaggregated, agile, and cloud native. Why does it need to do this? It is just because of the 5G use cases and the varied type of requirement it poses on the network. And one other important point about the challenges, meeting the cost optimization that is required while deploying networks at this scale. Lastly, about control and automation, the software on the aggregation networks needs to be SDN NFV enabled, and they should be able to orchestrate services and have the ability to do analytics. Shaji?
Now we will talk about the network architecture that actually makes this possible. So to expand on what Sterling and Nanda alluded to in the previous slides, basically, let's start off with the left of the network, which is the access portion of the network. And then you have the aggregation, transport, and the cloud, and the core and the DC network. Typically, this is how most architectures look like. This is a simplified view. Your network may have multiple segregation points like a pre-aggregation in between. But for all practical purposes, let's start with this basic topology. So what you see here is on the access side, you have both wireline and wireless. So in the wireline, what's happening is the passive optical networks, right? They're actually going in from 1 gigabit to XGS PON and NG PON 2 in the near future. So as those speeds increase, the aggregation point basically has to now scale up. Likewise, on the Ethernet access, fiber to home, fiber to curb, here in the US, you can basically find data rates all the way from 500 Mbps all the way right up to 1 gigabit. And likewise, in many other countries, basically that is pretty much the case. So the standard carrier Ethernets, even to the consumer side, it's basically increasing in scale. And on the wireless side, you basically have both fixed wireless and mobile wireless. So the mobile wireless, we're basically going from 4G to 5G. So the data rates that you're going to see on that aggregation side, particularly on the backhaul side, basically increases by a very large margin. So essentially what that boils down to is basically you need a network architecture that scales along with your current needs plus your future needs. At the same time, you basically need something that actually interworks with your existing solution. And plus it's forward compatible with the existing new technologies that are coming in. So how do you actually multiplex all this traffic and break it across to the metro and to your optical transport network? You would need some kind of coherent device to be basically there. Optical networking is the way to go because it's much cheaper as you get into higher speeds. So essentially your aggregation, your broadband aggregation strategy really needs to look at a couple of things. Scale in terms of capabilities, it has to meet the existing requirements, which is basically, it can be all over the map because the provider edge is pretty much complicated area. You may have an existing transport, and when you want to bring in, your first option is basically to scale the bandwidth, and then basically prep it up so that the network can converge into a simpler architecture. For instance, you may start off with a full IP MPLS with RSVP signaling, which means there is a lot of state information. Now at higher densities, now you're going to increase the burden on that network. And you may want to reduce that state information, decouple it from that, from a control plane perspective. So your pathways are basically using your existing MPLS network, data plane, and make the signaling much more simpler. So segment routing becomes a key requirement. And over time, you may want to go IPv6 end-to-end to keep your network much more simpler. So essentially, your network fabric needs to be able to support software and hardware, need to be able to support that transition from your current network to intermediate to long-term. So SRv6 would be that long-term option. So, and future technologies as they evolve, you need to be able to take in the latest and greatest in terms of speeds and feeds, as well as in terms of optical capabilities, like pluggable interfaces are now coming in. So 400 gig, 800 gig. So space, power, all of those things basically come into consideration. And how do you do this in a cost-effective manner while keeping the network much more simpler? So essentially, you need a strategy where that same piece of software is basically running coupled with capable hardware, providing you a different capability across those segments: access, aggregation, transport, and cloud, core, and DC. So you need a uniform strategy to bring that CapEx and OpEx down. So essentially, how would we enable that? So let's look at what a software architecture would look like. Next slide, please, Nanda.
Yeah, Shaji, before you
Sure.
We move on, just wanted to point out that you would see an Edgecore platform and each of the access and the aggregation points. I mean, the platforms are versatile, and you can flexibly deploy for different access points. But service providers need different capacities to support the different capacities to support their requirements. So just wanted to mention that the port configurations and the capacities required are all listed here in terms of whatever the service provider requires. So I think next we have a poll coming up before we move on to the software.
Yes, that is right. Thanks, thanks to both of you. So let's take the poll question and see what comes in, and then we'll continue with the presentation. So for the audience, you should have the poll question up, and it is, what kind of switching capacity do service providers require for broadband aggregation routers? And you can see there are three options here: 800 gigabits, 2.4 terabits, or 4 terabits and beyond. So this is the capacity of the switch to meet that application. I'll give a moment for the audience to respond. And kind of while I wait, one thing that occurred to me as we're discussing is we're talking about aggregation and disaggregation, and I kind of had to just give a bit of thought to that. So the aggregation is the traffic of the network. The function of this portion of the network is very much aggregating traffic. And what we're doing is talking about the network elements and disaggregating the network element, breaking that box up into hardware and software components. But the function of that element is aggregating traffic, so it gets a little bit weird to talk about this segment in disaggregation, I realize, as we go through. Let me push these results out, if I can, and see where we've come up. Maybe give one more push, see if there is a straggler. Yeah, so I guess, Nanda, we'll let you, as the hardware guy, take your views on this. 2.4 terabits, about half the audience, and then 4.4 terabits and above, almost a third, and then the last one was 8 gig, but really a lot of gelling around the 2.4. Is that what you'd expect, or is that reasonable? Oh, you're on mute, I believe.
Yeah, sorry. So this very well aligns with what our understanding is. We have started seeing, I mean, the aggregation networks were predominantly close to 1 terabits. The 800 gig capacity was what was deployed, but we have started seeing service providers move into multi-tera. And this perfectly aligns with our strategy of where customers are heading. And it is good to see that being reinforced by our attendees here.
All right, excellent. Let's continue on.
So in the previous section, we talked about the need for aggregation and what you would need. So from a software perspective, what you need is basically a piece of software that runs uniformly across one edge of the network to the other edge of the network. So how might you actually tackle this problem, right? So as a software vendor, we are thinking in terms of abstractions. So typically, as and when a new forwarding ASIC comes up, our software basically has to remain pretty much the same from an end user's perspective. But at the same time, being able to assimilate the newer capabilities that are coming in on the forwarding ASIC. So Nanda mentioned 800 gig to terabit scale. So basically, when that new network fabric comes in, it's either a fixed pipeline switch, which has fixed functions, or it might be a programmable kind of device which comes in. So then you need a data plane abstraction layer which can work seamlessly across both the existing ones that are 800 gig capable and the terabit scale. And it also needs to be able to take in all the peripherals that go along with any network element that comes in. So it can be as simple as things like fan control, power control, and all the buses on the system, plus board management capabilities for network visibility, and the forwarding ASIC, plus the optics that go along with it. So you need a software abstraction for that. So that data plane abstraction layer needs to be there, which presents a complete hardware abstraction. So irrespective of the type of hardware, incoming hardware, that hardware abstraction layer needs to present a common view to the control plane software. And the control plane software needs to be able to take in both the present network interworking. So it has to have full layer 2 switching, layer 3 capabilities in terms of IP, V4 and V6, because some networks are still in the transition stage. So we need to be able to cater to both kinds of routing and switching. So the common protocols basically that come into the picture are BGP, ISIS, OSPF. That's a given. And plus MPLS. And MPLS networks can be of many different types, depending upon how old your network is or how recently you rolled out MPLS. So basically, it can go all the way from static signaling with the LDP, or it can be RSVP or BGP based signaling to the latest ones, which actually have eVPN capabilities. So essentially, your control plane needs to be pretty versatile. So on top of this hardware abstraction, you have a seamless control plane, which works and can bring in new standards that are coming in. Because these standards, the IETF standards are evolving. Even BGP, ISIS, OSPF, they're actually coming up with newer standards. So you need a control plane that is robust, that can meet your existing requirements in terms of scale and capacity. Plus also, it's future ready so that you can actually take your network to that next transition phase in the network where you want to make your control planes much more simpler. Now, to manage all of this, you need a management plane. And most of the networks that are out there have their own management philosophy. Some can be element management systems, some are controller-based, and there are tiered hierarchies of controllers for different segments. So essentially, this incoming operating system needs to be part of that existing management framework. So the key requirements there would be, at the base level, it needs to have a robust CLI. It needs to have a transaction-oriented management system so that you can commit and roll back your capabilities as you're bringing in new capabilities into the network. Needs to support the day one configuration, which is basically things like call home protocols, basically. And need a very sound framework which can support both netconf as well as openconfig and any new network management paradigm that might exist. So you need a common data model to manage all the managed objects that are coming in, the hardware elements as well as the software elements that are coming in. So that actually constitutes the basic level of the operating system itself. Plus, as we are getting into the newer networks, what we are finding is basically it's pretty much evolving the same way your consumer software evolved. So essentially, it needs to be running in a virtualized environment, in a containerized environment. So your control plane basically needs to be a set of microservices that actually run and can expand at will. So the cloud scale piece of the equation comes in here. So those are all the attributes that need to be in the operating system, plus the ability for you to actually provide innovation on top. And basically what we are seeing is people want to write their own telemetry interfaces on top of this network management platform and their own automation frameworks that they want to bring in, test and automation framework. So essentially you need to have APIs onto each one of these layers, the control data plane as well as management plane, for you to be able to write vertical applications. So in terms of software, you need that common framework that runs seamlessly across from one end of the network to the other. So this is in a nutshell what that ideal operating system would look like. And we at IPI have created a software solution that actually matches these key attributes. Excuse me. Over to you, Nanda.
Yeah, thanks, Shaji. So just like what Shaji mentioned, the things that are done in the software to make it, an open, well abstracted system that can manage any hardware and anywhere in the network. So similarly, something similar is done on the hardware platforms. The hardware platforms are designed to be open, and we have an install environment which is standardized. So any operating system, not the OGNAS, any operating system can be instantiated, downloaded and instantiated on it and put into service. So this is something we do on the hardware platforms. So Shaji, moving on to the next slide.
Now, we described about the network operating system, but the network management is also the key aspect here. So network automation becomes a key requirement as you're deploying networks on scale. So now that the networks are becoming cloud scale, essentially what you need is, at the very basic framework level, you need to be able to take in a telemetry, then a fault configuration, auditing, and basically also provide integration with the third-party systems that are out there. So essentially, what you have is a domain controller that actually works with that network operating system. On top of that, there might be network elements on top of this controller, which actually provide that service automation, analytics, so that you have better visibility into the system. Because as you get into these higher speeds, you have to monitor right from the radio all the way to the optical component, plus your standard network protocols. And you basically have to look at an integrated way to get an end-to-end view of the network. And also being able to orchestrate the services on scale. Because as and when you're adding these services, you want a seamless capability so that you can basically pretty much start a service based on complete automation. So essentially, you need these three elements, the service automation, the network analytics, and a service bus to integrate with your existing systems that are collecting the data, because you might already have a system that is in place. So how do you bring this new operating system and the new hardware, open hardware, and bring it into and make it a part of your existing framework? So you need those telemetry interfaces as well. So basically, network automation platform now becomes the key, because you have to deploy this network on scale. Over to you, Nanda. So we described how you might look at hardware and software combination, open hardware and software combination. So here's a case study. So this is a case study based on actual deployment. So here, this is a mixed mode network aggregation story here. So in this particular case, what we are showing here is an existing network, which basically is IP MPLS heavy. Essentially, it has a BGP-LU and based network, and labeled unicast-based network. And the cell sites are basically getting converged from 4G to 5G. So there are mixed modes of operation here. So side by side, there are existing devices on the core side of the network that the service provider has. So in this case, the things that we need to do on the network is, on day one, being able to come in with IP MPLS capabilities and provide L2 and L3 VPN. And over time, this particular network is also providing broadband aggregation. So that same network basically now has to provide gatewaying access. On that provider right side, it is also bringing in OLTs. And those OLTs are basically going to provide symmetrical service, XGS-PON. So essentially, what you saw in a couple of diagrams back, this is actually a network where we are actually bringing in the software and hardware. And timing is also important here, because now we have to provide 1588 timing, and we have to actually get the timing from the GPS source that is provided in the network. So essentially, the hardware platform has to be capable of providing 1588 and synchronous Ethernet towards the cell tower. So you have 5G NR radios being deployed. The existing 4G network is in place. And the backhaul is basically through pseudo-wire on the 4G network, essentially using L2 VPN. And this network is also in transition in the sense that they are providing, they're rolling out eVPN services. So, so here's a network that is in transition. And over time, the end goal for this particular customer is to basically get into an end-to-end SRv6 network. So the network elements that are already in place in this particular network are capable of actually transitioning across. So currently, it provides LDP RSVP-based signaling. And in the intermediate term, they will decouple that RSVP framework and essentially turn on the software capabilities that we have running on that platform to use that MPLS data plane and provide SRv4. And then finally, when the network is at the state where all the network elements are in place, they want to actually go and cut over to SRv6. And this can happen in stages. So essentially, you can come into the network and put the network element, scale the capacity. That would be the day one requirement, without changing anything else on the network management side. And it seamlessly plugs into that existing NMS system, which is basically managing it through netconf. And over time, they want to get into open config-based data model. So this is one network which actually has all the attributes that we talked about. And the scale, the capacity, interworking, and the ability to actually bring in the latest and greatest in pieces of hardware. And when the pluggables actually come in, this would be capable of actually going to 400 gigs. So this is one one case study where it's a mixed mode network. Broadband aggregation, you have fixed wireless, 4G, 5G, as well as the aggregation for carrier Ethernet and fiber to the curb using OLT based system. Over to you, Nanda.
Yeah, so just on this 5G and the 4G, 5G case study, I just want to comment that from the hardware platform standpoint, meaning the white box standpoint, we give a special emphasis and focus on our designs and choice of components to achieve the kind of timing accuracy. I mean, here, it's not just meeting the 5G timing accuracy, but exceeding it. So we pay special attention to choose the oscillators, the DPLLs, the FPGAs, and the time stamping devices to ensure we are well ahead of the requirements that are specified for 5G. So we'll go to the next slide, Shaji.
Yeah, and we've got our final poll, so let's cover that, and then we'll move on to the final portion of the presentation. So the poll question should be up. Are service provider networks ready for the 400 gigabit pluggable transition? We've talked a little bit about 400 gig pluggables here, and we have sessions that cover this as well as a full session, but we just wanted to get a kind of a pulse on this audience. If you're a service provider, answer on behalf of your own network. If you're a supplier into the industry, from your discussions, is your sense that they're ready? And it's quite simple, yes, no, or I guess somewhere in between. While we wait to get the results, let me just take one, and maybe it's a quick question, but one that came in, Shaji, relative to your presentation. There's a question about segment routing over MPLS versus SR segment routing for V6 networks. Just to clarify, the segment routing MPLS, is that something from your company that's doable today? I guess the gist of the question is that SR V6 is not quite here yet, and they're asking about the viability of commercialization of the segment routing V4 MPLS.
Yes. So we have networks that are actually basically they have aggressive plans to actually roll out. So we are currently basically testing it out on carrier networks. So in terms of solution, yes, we have full capability for SR V4 with MPLS interworking. Yes.
Okay, that's what it sounded like from your case study, and then I saw the question, so just wanted to clarify. Let me push the results here. Shaji, I guess I'll let you be the first comment. Yeah, interesting. I'll let you comment first, and Nanda, if you want to add. So are they ready? Somewhat, 2/3 of the audience, pretty resounding. And then the yes, no's mixed. So pretty mixed bag. Well, mixed, the view is mixed, no matter how you slice it. Not quite ready. Shaji, any surprise?
No, it's not surprising at all because, as you might see, the 5G rollouts are still in place. The broadband network aggregation is still happening. And plus, there are other challenges that you need to basically overcome. First, the space, power, cooling for all these optics, the pluggable optics that are coming in. First, the network fabric needs to be in place, plus backward compatibility. That's a key issue, right? So what would happen is on the data centers, this would happen first because that is the most logical point where you can actually bring in the pluggables. And then over time, this will happen on the other edge of the network. So it is not surprising at all. I expect to see this happening. This happened even with the 100 gig transition from the 10 to 40 to 100 gig transition. It happened exactly the same way. So the same cadence would happen.
Nanda, anything you want to add here?
Yeah, so not surprised by the results. And I think there are reasons for this. There are a lot of legacy platforms in service provider networks. They are not capable of hosting these high-powered 400G pluggables. So, I mean, this requires, I mean, cost is another factor, but the ability of, the platforms that are, service providers are deploying, they need to ensure that, they are getting platforms which can support 400G high-powered, long-reach optics. So this is something, is starting to happen. Service providers are starting to ask. But yeah, they always have to deal with the legacy that they already have in the network.
Yeah, consistent with what we're seeing as well. We've got, want to leave time for questions, so we've got one section to get through. So if we can move through here fairly quickly and wrap up, we'll get to a couple questions at the end as well. And
Sure.
I think, is this Shaji? Go ahead.
Yep. So basically, in this case, we are showing the requirements for. You talked a little bit about. Sterling talked a little bit about the RAN density, densification. So with particularly with 5G, as we decompose the radio element, you basically have decomposing the baseband essentially. So you need a lot of bandwidth basically right at that edge of that network as well. So here we are showing, how you could dimension the capacity, and with our software running on top of Edgecore platform. So in this case, it's a greenfield. Essentially, we have shown some with the millimeter wave as well as with various different kinds of transport, right, and different kinds of radio configurations. We've given you a sample here, but it's not necessarily representative of everything that is out there. So this is an ideal network that we kind of model, but essentially, you can pretty much build out the scale and capacity using a combination of software and hardware for a greenfield deployment. Nanda, if you want to quickly touch upon the hardware aspect here.
Yeah, so I think Shaji, you covered in terms of the port configuration and capacity requirements. Go ahead with the CRAN. I will with the brownfield and the CRAN. I think I'll just add a thought at the end.
Sure. Okay, so the brownfield, basically you would have CPRI compliant radios as well as eCPRI radios that are coming in. I talked about the network, the packet side of the network, but now we talk about the radio side of the network, right? So you bring in front haul. So you would have a front haul gateway, and that has to aggregate everything into a packet switch. Behind that, you basically have the BBU hotel, as they call it. That is an existing one. So the 4G actually connects. So on day one, the 4G connects to the BBU hotel there. And then you basically have the virtualization, the virtualized CU and DU kind of split combinations for the 5G radio. So you need to be able to take both CPRI and eCPRI traffic at the front end. So essentially now you need more bandwidth going into that aggregation side. And on to the next slide, please. I'll quickly touch upon microsites as well. So here, this is basically a variant of the previous one, a subset of that. So you have micro RRUs, basically the radio units, essentially with CPRI connecting to the CSR. And then in this case, the CSR basically is a platform that aggregates both the eCPRI as well as CPRI, and essentially connecting to the aggregation device. And I've given some sample configurations here, what we can do for a microsite, basically. On to you, Nanda, please.
So Shaji, to summarize, from a hardware standpoint, there are two platforms we have listed here, and both of them are well capable to support the hub router requirements, whether it is a CRAN microsite, CRAN brownfield, or a greenfield type of requirement. They can do these platforms capable of front haul for the eCPRI, and also the DCSG and the access routing functions or the hub routing functions. So we'll skip to the next slide. So this is a summary slide on Edgecore. Why Edgecore? I think Edgecore has a very wide portfolio of solutions, not just on the aggregation networks we are talking about, also on the access and the core network requirements. We have extensive hardware software expertise, and we have a complete solution from access, aggregation, and core platforms or solutions. So we have a worldwide presence. We have a global service and tech support capability, and we have a diverse channel partner ecosystem to reach service providers in all regions globally. So overall, we feel we have the best-in-class solutions to address broadband aggregation requirement. Our platforms are versatile, ability to support from the lowest capacities to the higher capacities required, and the designs are very optimized for latency and the timing accuracy requirements. And overall, we have a proven and high quality solutions, and we can deliver these directly to service providers. Shaji, next slide.
Sure. So IP Infusion's unique value is in innovation. Basically, we have been in continuous operation, as we said, building solutions based on standards, IEEE, ITU, IETF, and new and evolving standards. And we build a common software platform with a hardware abstraction that can work across anything that is latest and greatest in networking, both vertically as well as horizontally disaggregated, all the way from optics to network ASICs, basically, and anything in between. And essentially, it gives you a way to streamline your operations with the best of breed technology, and with simplify, but at the same time, making that complex networking simplified by offering a comprehensive control and management plane solution, which can do both PLI, SNMP, netconf, OpenConfig, and whatever the future architecture may evolve to. And network automation on scale, the ability to bring in all these diverse network elements into a common framework. So it allows you to go from the networks of today into the network of future, offering you that seamless migration. So business agility to offer services cheaper, better, faster at a lower TCO without any kind of vendor lock-in. And we do this while de-risking your operation with a flexible consumption model. You can start pretty much on any segment of the network and bring in the solutions based on your comfort level, scale, add capacity, turn on new features, and essentially at the same time meeting your objective in lowering the CapEx and OpEx by having a wide plethora of solutions to choose from. And last but not the least, providing world-class technical support for both the hardware and the software. So you get an OEM-like experience from a single window, essentially being able to call one number for your solution, so de-risking it. So essentially our essence is simple, scalable, seamless interworking network. Basically, that's what we do in a nutshell. What do you
All right. Thanks, both of you. I believe we are moving into the Q&A. We have a few minutes left. We do have a few questions in, but if you do have a question, now's the time to ask, and we'll see if we can get to it in the remaining few moments. There's some questions that can kind of go around a theme, and maybe we'll start with that. Nanda, I'll let you lead off, but really the theme of the questions I think can be described as can you explain why an open disaggregated solution that's kind of this architecture that's been talked about would be chosen by a service provider compared to traditional? And I'll let you, Nanda, start, and maybe Shaji, if you want to add, and then I've got kind of a little bit of a deeper dive into that. But Nanda, do you want to kick that off?
Yeah. So I think the question did mention is it even being deployed or is it even being preferred? Mm-hmm. Just for the record, I mean, open disaggregated solutions are being deployed by the largest tier one service providers currently. I mean, they've been deploying it for a few years now. So this is not something new. It is adopted. Largest tier ones have seen the value, and they continue to deploy and grow their networks. So that's the first point. I think, why are they doing it? I mean, earlier, maybe a couple of years ago, we would have said flexibility, cost optimization. But I want to bring up an important point that currently, after COVID, we have seen a huge supply chain constraint. So any service provider, who's deployed a locked-in solution, a hardware, software from one vendor, they kind of have to wait for that vendor to supply. And operators who have gone with the open disaggregated model have had the choice to second source. So they have been able to go after, hardware suppliers who can provide an option. So I think, currently at the point we are with the supply chain and the difficulty in getting platforms, I think, chips and getting platforms into your network, I think, that is one of the key, selling points for this model.
All right, thank you. Shaji, anything to add on that? And then we'll go to the next one.
So we have deployments across the globe, basically from all the way from open transport, basically carrier access, CSRs that are deployed. So the use cases that I brought up, all of those are actually deployed. And we have one of the largest internet exchanges dating as far back as 3 years ago, basically operationalizing on our and the Edgecore solution, basically one of the largest exchanges, internet exchanges. So essentially we have deployments across all categories. So, and last but not the least, we added 50 new logos actually in the past 7-8 months that we have been in operation.
All right, so, and then just to drill down specifically, and I don't know if this would go to Nanda or to Shaji, but there was a specific question about reliability. Given these networks that you have jointly deployed and separately, reliability-wise, do these match what service providers would expect out of a traditional architecture? That seems to be one of the questions coming in. Maybe Shaji and then Nanda, if you want to add.
Absolutely. From a software standpoint, we have to meet that strict 4 nines reliability. Why? Because it is going into the core areas, right? Like the edge aggregation, particularly. If it goes down, it takes down your network. So essentially, we have all the resiliency that you would expect. From a protocol standpoint, we basically provide that reliability in terms of BGP resiliency, right? Like graceful restart, the ability to basically do ring protection switching, a fast reroute for MPLS. So we have all the elements, BFT. So we have to meet those requirements before we even get into the network. If we don't meet those criteria, basically, we don't even pass that homologation stage. So essentially, yes. And we have many of these networks, basically, to give you an example, we have a 4 million subscriber network deep in the Amazon jungle, and it's operating basically at Sky Networks. And it has been in continuous operation without a single incident. And we have one of the largest deployments providing that entire backbone to Chile. Mundo Pacifico is one such network. So there are numerous examples that we can quote. So yes, they are ready for prime time and they're in deployment. And in many cases, they've been in deployment for over 2 to 3 years now.
All right, Nanda, anything you want to add on that from a hardware side? And then we'll probably close out there because we're at the hour. Go ahead.
Yeah, so yes, we put a very special emphasis on quality. And, in some of the large deployments, what we have seen is that, that quality emphasis has paid off. Some of the return rates on our platforms are lower than even traditional OEMs. So, open disaggregated does not mean that there is a compromise on quality. It is to meet and exceed the quality expectations of service providers.
All right, excellent. We do have more questions. Unfortunately, we're out of time, so we'll have to close out here. For the audience, if the survey should have popped up, if you can just take a moment to fill that out before you close out. And with that, I'd like to thank our sponsors, Edgecore and IP Infusion, and Shaji and Nanda on behalf of those companies, and also the audience. Thank you for tuning in and your good questions today. Thank you, everybody.
Yep. Thank you, Shaji. Thank you, everyone.
Thank you, everyone.